Hello guys, welcome to Tech Vitals. Today we are going to learn about logical volumes in Linux, and logical volumes are very important in Linux partitions, especially when we run out of the space in our physical volume. So whenever that happens, we can add additional drive and make it a logical drive by utilizing the logical volumes. So in this video, we are going to learn how to create the logical volumes and use them as logical drives. So at first, let's take a look at the brief description of how to create the logical volumes. The first process is to convert our Linux partitions into physical volume. So here we can see we have /dev/sda and /dev/stb converted into physical volume. Then we have to create a volume group. So here we have a volume group named data, and then we have to add those physical volumes into this volume group. And after adding the physical volumes into our volume group, we can create logical volumes. So here we can see out of this volume group, here we have 3 logical volumes created. First named video, second web, and third doc. So we are going to follow the same procedure to convert our MBR and GPT partitions into logical volumes. If you are following along with the series, then we have created 2 partitions in our virtual server, one using the fdisk command for the MBR partition and another using zdisk command for the GPT partition. So if we type fdisk and then check the list, then this /dev/sdb is the MBR partition that we created using fdisk that has the size of 20 GB, and this /dev/sdc is the GPT partition that we created using zdisk command with also the size of 20 GB. Now in this video we are going to convert these 2 partitions into logical volumes and use them as the logical drives. To use any disk partition as a logical volume, first of all we need to change their partition type. So here in the /dev/sdb we can see we have 4 partitions. The first partition STB1 is the Linux swap type partition. Then this STB2 is the extended partition, and from this extended partition we have these 2 logical partitions. And in this /dev/sdc disk we also have 3 partitions. The first partition has the type of Linux swap, and the remaining 2 has the type of default Linux type partition. So if you want to make these 2 drive as logical volumes, we have to change their partition type into logical volume partition type. So we need to override these 2 partitions. Now at first, let's override our MBR partition, that is /dev/sdb. So let's clear the screen, and now let's use fdisk command for /dev/sdb. Now if you type M, it will give us the menu with all the activities that we can perform in this disk. So here we can see to create a new DOS partition table, the command we need to use is O. So let's press O and press enter. Now to add new partition we can press N, and let's create a primary partition. Type P and hit enter. Okay, so it is the first partition, so the partition number will be 1, and the first sector we want to make it default, so let's press enter. And what I want is I want to create just 1 partition with the total size of this disk. So for the last sector also I'm going to give the default value. Okay, so now it is saying partition number 1 contains a swap signature. Do you want to remove the signature? So it is simply asking, do we want to override this disk? So yes. Let's press Y and press enter. Now it is saying the signature will be removed by a write command. That means we have to press W to write on this disk. So let's type W and press enter. Okay, so all the changes will take place when we reboot our machine. So before rebooting, let's override our GPT partition 2. So we are going to use zdisk command for /dev/stc. Here we have to type question mark for the menu. Now to create a new empty GOID partition table or GPT partition, we have to type O. So let's type O and press enter. Now do you want to proceed or not? Yes, we do. Now to create a new partition, type N and press enter. So it's going to be the partition number 1. First sector is going to be default as well as last sector. And here we have to change the hex code so that we can make it the type of logical volume. So to see the codes, we can type capital L and press enter. Now the type we are looking is Linux logical volume, Linux LVM, and the hex code for this partition type is 8E00. So let's hit enter first, and now we can give the hex code, that is 8E00. Press the enter, and to save all the changes we have to type W and press the enter, and let's hit Y to proceed. Okay, and actually we forgot to change the partition type of our MBR partition, so let's try to do it. Now to change the partition type, T is the command that we want to use. So let's type T. Now to see the list of all the hex code, we can type L and press enter. And we are looking for this Linux logical volume type, and the hex code for this is 8E. So let's give this hex code 8E. Press enter. And now type W to save this change. Okay, so now we have overwrite both MBR and GPT partition, and now we are ready to reboot our machine. So let's reboot. Okay, now our virtual machine is rebooting. Okay, so now we have rebooted our machine. Now if we check fdisk and see the list, then you can see for this /dev/sdb hard disk, which is MBR partition, we have just one partition, SDB1, with the type of Linux logical volume. And for this /dev/sdc, which is a GPT partition, here also we have just one partition with the type of Linux LVM. Now, since both of them are the type of Linux logical volume, now we can convert them into the logical volumes. So if we check the procedure here, the first step is to turn our hard disk into the physical volume. So let's convert our /dev/stb and /dev/sdc into the physical volume. So let's clear the screen. To create the physical volume, we use the command pvcreate, that is physical volume create. And now we can give the name of our hard disk, that is /dev/sdb1 and /dev/sdc1. Let's press enter. Now we have to type Y to continue the process. Okay, so now we have successfully created two physical volumes, /dev/sdb1 and /dev/sdc1. If we type pv display, then it will give us the detailed information about these two physical volumes, /dev/sdb1 with the size of 20 GB and /dev/sdc1 with also the size of 20 GB. Okay, now the next thing is we have to create a volume group. So let's create a volume group. To create the volume group, we use the command vgcreate, that is volume group create. And now we have to give the name of this volume group. So let's give the name of logical_group. Now we can add those two physical volumes in this volume group. So /dev/sdb1 and /dev/sdc1, and now press the enter. Okay, so now the volume group named logical group has been successfully created, and we have added these two physical volumes in our volume group. If we type pvcreate, then we can see we have this volume group named logcial_group, and the size of this volume group is 39.99 GB, that is almost 40 GB. Okay, so now the volume group has been created. Now the final step is to create the logical volumes out of this volume group. So let's create the logical volumes. Now to create the logical volume, we use the command lvcreate, and now we have to define the size of this logical volume. So give -l attribute, and now we have to give the size. So we are making this logical volume for this volume group which has the size of 39.99 GB. So let's give the same size for this logical volume, that is 39.99 GB. And now we have to give the name for this logical volume, so -n, and now we'll give the name for this logical volume. So let's give it the name of testing, and now we'll give the name of the volume group that we want to include in this logical volume. So the name of our volume group is logical_group. Let's press the enter. Okay, so the logical volume named testing has been created with the size of 39.99 GB. If we type lv display and we scroll up, then here we can see the logical volume that we just created named testing, and the path of this logical volume is /dev/logical_group/testing. So this is our volume group and this is our logical volume. We can see the volume group here as well, and the size of logical volume is 39.99 GB. Now the logical volume has been created. Now the only thing left is to mount this logical volume. So first let's create a mount point for this logical volume. So let's go to /mnt, and in this directory let's create a directory named logical_data. Sorry, I had to use the sudo command here. Okay, so now in this mnt directory we have this logical_data, and we are going to use this directory as the mount point for our logical volume. So now we are going to use the fstab file to automatically mount our logical volume as we did in the previous video. So let's use the vi editor and let's open that fstab file which is inside hc directory. Press enter. Okay, now let's go to our insert mode, and here in the first column we will give the path of our logical volume. So the path was /dev/logical_group, which is the name of our volume group, /testing, which is the name of our logical volume. So in the second column we will give the mount point of our logical volume. So our mount point is /mnt/logical_data. Now in the third column we define the file system, so we can either give ext4 or xfs. So for now let's give ext4, and for the fourth column we have to give the options, and let's give default option, and for the fifth column we can give 1, and for the sixth column let's give 2. Okay, now let's save this. Now let's check mount -a to check if there are any error in our file system. Okay, so we got the error. That is because we didn't define the file system before mounting it into our fstab file. So let's try to define the file system first. So this is for the ext4 file system, and the path is /dev/ logical underscore group slash testing. Okay, so file system has been created, and now let's try to run the mount-a command again. Okay, so now we didn't get any error. Now if we type mount, now you can see we have successfully created and mounted our logical volume. So this is our logical volume, and the mount point is /mnt/logical data. The type is ext4 file system, and these are just the default options we gave to this logical volume. Now if you want to delete these partitions, then you cannot just go into the F disk or Z disk and delete the partition like we did before, because to delete the logical volume we have to follow the exact opposite process. So if you want to delete these logical volumes, the first thing you have to do is you have to unmount this logical volume. So let's clear the screen first. Now the first thing is to unmount the logical volume. So you have to type umount and then give the mount point, that is /mnt/logical underscore data. Then after unmounting the logical volume, you have to remove that logical volume first. To remove the logical volume, you use the command lvremove and then give the name of logical volume, that is testing. Then you have to remove the volume group. So to remove the volume group, you use the command vgcreate and the name of volume group, that is logical underscore group. After this, you also have to remove the physical volumes. So you use the command pvremove and then those two physical volumes, they are /dev/sdb1 and /dev/sdc1. And only after all these steps you can go to F disk and Z disk and then delete that partition. So that's how you create and delete the logical volumes. Okay, so now we have the logical volume named testing. So if we type lv display, we can see that this is our logical volume that we created. Now let's say we added another hard disk in our Linux server and we want to add that hard disk into this logical volume. Then the process is slightly different. So first thing, let's say we added a hard disk named /dev/sdd. Now we can either make this hard disk as the MBR partition or the GPT partition. So no matter what partition do we use, the partition type for this hard disk must be the Linux logical volume. So we know the hex code. For the MBR partition using F disk, we use the hex code 8E for the logical volume partition type, and for the GPT partition we use the hex code 8E00 to make this the logical volume type partition. And after that we have to create a physical volume for this new hard disk. So the command is pvcreate and then we have to give the partition, that is /dev/sdd1. And after creating the physical volume, we have to add this physical volume to the same volume group. So the name of our volume group is logical underscore group, and to add that new physical volume into our volume group, we use the command vgextend, that is volume group extend. Then we give the name of our volume group, that is logical underscore group, and then add the new physical volume, that is /dev/sdd1. Now after extending our volume group, or after adding a new physical volume in our volume group, the size of our volume group will increase. So before, the size of our volume group was 39.99 GB, and now let's say if the size of this /dev/sdd1 is 20 GB, then 39.99 plus 20 is 59.99 GB. So the size of our volume group will increase by another 20 GB. And after adding this new physical volume into our volume group, we will have to extend or increase the size of our logical volume too. So the name of our logical volume is testing. So to extend this testing logical volume, we use the command lvextend, that is logical volume extend, and then we have to define the size. So if the new hard disk is 20 GB of size, then we have to extend our logical volume with the same amount of size, that is 20 GB. And then we will have to give the full path of our logical volume, that is /dev /logical_group/testing. Okay, so after extending our logical volume, we have to resize our logical volume. And to resize our logical volume, we use the command resize to/fs and then the full path of our logical volume, that is /dev /logical_group/testing. And then our logical volume will be resized, and that new physical volume, that is /dev /std1, will also get added into our testing logical volume. And also notice that this resize to/fs only works for the ext4 file system. But if we have used xfs file system for our logical volume, then instead of this resize to/fs, we'll use xfs_grow/fs. So that's a small change between ext4 and xfs file system. And that's it. That's how you can add multiple physical volumes into the same logical volumes. So in this video, we learned how to create the logical volumes, how to delete the logical volumes, and how to add more physical volumes into the same logical volumes. So I hope this video was really helpful for all of you. And that's gonna do it for this video. I'll see you soon with the next video. Till then, keep learning. Goodbye.